Good. So I've been talking to Mike Uschold about an issue which I haven't really thought enough about, which is the degree to which the various logical and even logico-mathematical concerns that we're interested in, about the degree to which those concerns are practically relevant. And by practically relevant, I mean relevant to the users of the ontology, the upper ontology, who are using it not directly in any case, they're using it indirectly because they're using domain ontologies which have been built by downward population. So the idea is that you have an upper ontology, somebody builds a cell ontology or a machine ontology or a power tool ontology using that upper ontology as a starting point, and the requirement which BFO has been trying to meet is that everyone who does that with a bit of care and perhaps with guidance from someone like Alan will be producing a domain ontology which, at least to some degree, will be interoperable with other ontologies which are built in the same way. I do not know to what degree these mathematico-logical concerns are relevant to achieving that end, but I think Alan and I share the view that we must be very, very careful to make sure that the upper ontology is logically rigorous, because if it's got logical holes in it, then things are going to break. And I'm going to repeat what I said yesterday. I think there's another concern which is equally important to the concern about logical rigor, which is the existence of good documentation. Because if people are going to build these ontologies in a way which is conformant to an upper-level ontology, they need to understand the upper-level ontology, and that means definitions in English. And I spent an hour yesterday trying to find DOLCE definitions in English, and I didn't realize that they do not exist. That's an issue. If you have a long 12-line first-order predicate calculus definition, that's going to be hard for people to reuse. There should not just be the first-order predicate logic. There should be an English explanation. All right. So the original problem that was faced, as I described yesterday, by the people working in biology when they suddenly realized that everything they learned in school was no longer relevant because they had all this genomic data, was how to integrate across all of these various different species and disciplines. And the idea came along with the gene ontology. Well, we can integrate by tagging all our data with ontologies. And so ontologies were incredibly successful. The ontology was very successful. Everyone said, I want some. There are now probably more than 379 ontologies in the BioPortal, which is a repository of bio-ontologies. And I recommend the BioPortal as a place to do searches on ontologies, but I don't recommend it if you want to find good ontologies, because of those 379, a very small fraction are any good. But the real problem is that, remember, the goal is to integrate data across domains, and you're going to use ontologies. You go to BioPortal, you're interested in the science of obesity, you have a lot of obesity data, so you put obesity in the search box, and then you get 3 ontologies, and then you get 7, 9, 10, 8, 9, 10, 11, 12, 13, 14. So I don't know how many there are, 74 ontologies which have the word obesity. Some of them share the same definitions, but most of them don't. And the links are done by text string matching, and they are notoriously unreliable. So chronic obstructive lung disease is mapped to common cold because they both are COLD. The links are not, but that's actually the topic of the next slide. So linked open data, we can solve this problem by linking. We can map the ontologies. That's what people say. They don't worry about the fact that there are 79 ontologies about obesity because we can map them all. And so mappings are expensive. They're fragile because the 2 sides of the mappings change independently. There's no way of keeping mappings up to date. Mappings don't work. We should all hate mappings. In order to minimize the need for mappings, we need one obesity ontology, and just one, a good obesity ontology. We need one ontology for diabetes. Then we need to organize these ontologies into higher level ontology, disease ontology, And then at the very top, we need a top-level ontology, which will be, again, one ontology to cover everything non-domain. I believe that the value to be gained by having one ontology for each domain overwhelms tremendously the value to be gained by being loyal to specific contexts. And I'll give you an example from my work with the Army. So the military has something called joint doctrine. Joint doctrine is a set of terms which everybody learns the meaning of, and it's drilled into them over and over again. And that means that when officers give commands, the officer will give the commands using terms from this set. Everyone will understand it, and so people don't get killed unnecessarily, only necessarily. Now, that's a real advantage. If people automatically, instinctively use certain words in the same ways with the same definitions, that brings benefits. And I think those benefits, when it comes to data sharing, which is the scientific equivalent of commanding, from this point of view, it's a matter of both cases a matter of communication. Then those benefits should be reaped as far as possible. And we should work hard on trying to teach people who live in different contexts that it's really not harmful to use words in this way when you are concerned with sharing your data. And most biologists were concerned and are concerned with sharing their data. We have to understand the technology of ontology reuse, ontology importing. And that's one of the side benefits of the OBO Foundry initiative, that software for supporting importing and reuse of ontologies was developed. Okay, good. All right, so that was the idea behind the OBO Foundry. So one ontology for each domain, modulo all of these issues. Now, the topic of this session is mappings between ontologies. I've said what I think about mappings. I don't think we should have mappings between ontologies. But now I'm going to tell you about some mappings which I think we probably should be thinking about. So I've given you the health warning, and now I will give you some speculation. So this is an example of, not mapping now, this is an example of what I believe is subclassing, exactly what you referred to. So ontology-based data access. Down here we have the sensor systems, SSI ontology, SSO ontology, sensor systems ontology. And we have observation, subclass of, so observation is a term in the sensor systems ontology, subclass of situation. We have observation value, subclass of region. We have feature of interest, subclass of event or object. So the other things are okay, but those particular subclassing assertions seem to me to be very peculiar. So it seems to me to be just wrong to say that an observation is a situation. An observation is something like an event. All right, now this is another example of a mapping, which you can find on the GFO site. And everything, so GFO has more things than other people have. So they have entities and they have items. Okay, so space-time entity maps to Dolce temporal region or Dolce spatial region. Okay, so it's a disjunctive category. A good rule in ontology building is you never have disjunctive categories, just as you never have negative categories. So there is no category non-Italian, because the world doesn't contain disjunction. That's something which comes into being because we have cognition. I think that a good ontology should have organization. This would not be a top-level ontology because there are only organizations in that small part of the universe with people in it. BFO will allow you to use classes, and not including them in the asserted version of the ontology is because there are no more entities in the world than persons and organizations, just because we have the term social being, which is defined, and where we only add terms to BFO or to any of the other ontologies that we develop, where there are entities corresponding to them. So there is no entity, so there is is your temperature. You have a quality, which is your temperature. Let's assume that you have swum in the waters of the Ganges when you were a teenager. There is no entity which is being such as to have swum in the waters of the Ganges, which you inheres in you and doesn't inhere in you. But somebody might find it very useful to have a class called people who swam in the waters of the Ganges. BFO will allow you to create a defined class. Now, disjunctions can be used willy-nilly in defined classes.
Don't put them in the upper.
Yeah, don't put them in the asserted ontology. Somebody who creates an ontology for a particular clinical trial might need a defined class ontology. They extend the reference ontology by adding defined classes.
Just another clarification concerning, let's say, negative categories, or do you call them disjunctive categories?
Disjunctive, negative, there are no such categories.
Okay, well, you do have at least two of them in BFO, namely independent continuance and immaterial entity.
No.
Of course,
They're not negative.
let me say.
Look at the definition.
Let me finish. When it comes to a, let's say, a disjunction, like dependent versus independent, of course it is very important to be able to name both cases. Okay? What is problematic is what people do, for instance, in library science, where they have category A, category B, category C, everything else. Of course, this is bad.
That's not a bad thing. Yeah.
This is bad. But when you have a disjunction among two things, among two categories, just naming the two as you actually did, dependent, independent, material, immaterial.
No, because we don't say that there are only two kinds of continuance.
No, you have a partition, a complete disjunctive partition in among continuants, which is dependent versus independent.
Where does it say that?
We don't close them in the active citation.
I'm looking at the picture at the beginning.
But remember, we're doing ontology. We never make the claim for completeness.
Okay. But anyway, the general problem is there, of course. By the way, if you have continuance, you have the notion of dependent continuance and independent continuance. Of course, this is a complete partition, a complete disjoint partition. Why not?
Because we don't believe in negative categories. Okay, so I used to be a philosopher. I studied logic in my youth. And that means that I know a lot about first-order predicate logic, and I know a lot about, and I became interested in ontology, and so I read a lot of work in ontology, which was ontological work. So it's the key to understanding ontology is to translate science into first-order predicate logic, and then the result, I think, is bad ontology. The ontological world is like a lattice. So you have the null set, and you have the universal set, and then you have various medium-sized things which can be combined in Boolean ways absolutely unrestrictedly. I think that's bad ontology. Because there is no entity in reality which is either a rabbit or a pair of spectacles. So if you want to give an assay of the kinds of entities existing in reality, if you are allowed to use disjunctive classes, you will end up counting everything infinitely more times than you would otherwise need to do. Actually, is that true, or just the square? The square. No, extra you will have this. If you need n categories and you allow disjunctive categories, then you'll have actually more than n squared. Okay, so can I address this topic? Nicola started off with this four-category ontology. So there are objects and object instances, object universals, and attribute instances, attribute universals, perhaps also process instances, process universals. Everything is either an instance of a universe or a universal. And BFO is absolutely loyal to that approach. So there are no entities which do not come in both forms, the instances and the universals. It seems to me that Dolce and GUFO break that because they have abstract entities. So that is a fracture point. And it seems to me that the abstract entities are a kind of cheating.
A lot of the operations that I see in there is ontologies aren't in a physical space. You map them are possibly in things in physical space. So they're things that occur in some immaterial mathematical world. And we use those quite regularly to say, you know, things in physical space behave according to meritological principles. Those principles and operations themselves are probably in an abstract space of some kind. So I'm not making claims here. I'm saying that there is some emphasis here, and therefore it's important to tease these out.
So I think that this is another fracture point between Sumo and all the other candidate upper-level ontologies. Sumo has a huge collection of mathematical entities. And the big problem is that most of them are defined in ways that mathematicians would turn up their noses at. And BFO, and this is mainly as a result of my being stubborn about this, BFO has resisted having anything mathematical. And the reason is that mathematics is a very dangerous area to dabble in because you very quickly get hit by all kinds of mathematical difficulties, which, if you're not careful, you will...
Are reliant on meritological criteria.
Yeah, I think what we need is something like qualitative meritopology. Yeah, and there is a lot of meritopology in BFO. We have spatial boundaries, we have temporal boundaries, we have process boundaries, we have object boundaries. There are no sets in BFO. As soon as you have sets, you have to choose a set theory. Now, the most attractive set theory, which is Frege's set theory, roughly speaking, or even Cantor's set theory, is logically inconsistent.
But can I ask a question that comes in the other direction? I want to say of a thing, this thing is a bond, and this bond is known as a floating rate note because it has an interest rate that has a formula, and one of the arguments of the formula is the LIBOR rate, and another argument is a number, and these are added. And I want to be able to just, in simple declarative ways, without being mathematical, declare these pieces of mathematics, because they enable me to classify one kind of bond as from another.
Yeah, and everything you just said is dealt with in the IAO. They're all information artifacts. I guess another feature of BFO, which I think we all share, BFO is on the border here. BFO is deliberately designed to be very small. That makes it teachable, and which means we need extra modules like IAO, social objects, which we're working on at the moment. Yeah, and I would be willing to go along with you there. All right. So the information artifacts are generically dependent continuous, which is a term in BFO. It includes what you need to do what you need to do. So it doesn't include what you need in order to do Lebesgue integral calculus or in order to do Hilbert space theory. But it does include all the things you need. And all the things you need to do a biological experiment and do the data processing on the data resulting from that biological experiment. All of those things we can deal with. But what we can't do is mathematics. We don't want to do mathematics because it's hard and life is short and BFO has to be small. So that's already 3 reasons. So this is a point which came up yesterday. So Robert complained that the mental functioning ontology has a theory of the mind which he didn't like. And I said, ontologies don't contain theories. They contain terms and definitions and axioms governing those terms. But they don't repeat psychology or mathematics, or that's not their purpose. We're not trying to redo science within this owly thing. We're trying to formalize the terminological parts of science to promote data sharing and ontology-based data access. All right, so I just want to mention that there is a paper which is at the moment subject to review by Celia Sepele, who was a postdoc in Buffalo, and Amanda Hicks, who is she works in the medical school in Florida, on a mapping of Dolce to BFO. This is it's a very, very careful piece of work which goes through all of the existing proposed mapping, including some of them that were mentioned earlier today. So this is just an example, and to find the relevant core which we share is going to be quite hard. Now this can illustrate some of the kinds of issues. So Dolce has arbitrary sum. I don't think this is a good term to have in an ontology because non-arbitrary sums are also arbitrary sums. So the sum of all the pieces in this laptop is not, sum means sum of objects. So that's a mistake. There are no arbitrary sums in the world. So what we need is some kind of benchmark, something which we can use as a basis for creating an ontology which is closer to the God's idea, and the benchmark is something like science. And that's the basis on which BFO was built. So, an object aggregate in BFO is a collection, a sum of objects and nothing else. A material entity is any sum of material that you care to mention, down to the level of molecules or even below. So that the sum of all the people in this room is an object aggregate. The sum of all the items in this room, including all the tables and oxygen molecules and so forth, is a material entity. Either including the paint on the wall or not including the paint on the wall. So, I should explain that Celia, who is the author of this slide, was working not just on a mapping between Dolce and BFO 2, but also including mappings between Dolce and BFO 1.
So, are they different or are they equivalent, the object aggregate?
These are equivalent, that's what it says, they're equivalent.
So why is that?
Because she designed the slide in that way. It looks nice. It looks
But when you say
symmetrical.
When you say equivalent, you mean it's the same class.
Yeah. All right. Actually, that topic will arise in the afternoon. These are just the principles that Celia used. So, whenever possible, map to the most specific BFO2 term. If there is no equivalence, map to the most specific superordinate term. And if more than one mapping is possible, then map to the union. That was the idea. So she was really working hard to try and get the complete mapping, but you can't do that with equivalence classes. So this is another part. So Dolce has feature. BFO1 has fiat object part, which is a subclass of Dolce feature. Object boundary is a subclass of Dolce feature. And BFO site is a subclass of Dolce feature. All right, so this is the final slide. Oh no, I have some more. This is Dolce. This is an expanded bit of Dolce. Now, achievement, accomplishment, and so on, very relevant to the small part of the universe which engages. We are working on an extension of BFO where just as some parts of Dolce relate to information entities which can be mapped to the IAO, so some parts of Dolce relate to things like achievements and accomplishments which will be mapped.
Is it part of BFO? Or
No, it's an extension of BFO. BFO has to be small, otherwise it will not have enough.
So BFO will remain according to
a true top-level ontology.
Whatever it is now, so it's not going to new pieces of BFO.
BFO is going to change in the light of the needs of its users. And when we have a critical mass of users doing physics, we will need to have terms for things like field, energy, and frame of reference.
But in BFO or in the extension?
I think all of those. Well, actually, that's a good question. I don't want to I think frame of reference will probably need to be in BFO because it's needed to do space and time in ways which physicists will.
So you're giving that stuff over there. It's where this argument belongs, right?
Well, we have temporal regions.
Of course.
And Nicola agrees with me.
On what?
That is absurd It's absurd to see a temporal location as a quality.
No, it is not absurd. We discussed that.
So when
let me make, to be honest, let me make a point, a problem in Dolce. Okay, so I recently realized that the way we distinguish between states and processes has problems. While reading Anthony Borgo's stuff, there is an example, because we base this distinction on mere ODB, and there are some processes that he mentioned, like moving, gliding, which are Homer and still they are processes according to the definition of this. So that, to be honest, we've been pretty naive in developing the ontology of perdurance in Dolce. We just based ourselves on some mainly linguistic work. These distinctions seem to be relevant in some cases. I agree with you again on this. Okay? Seem to be relevant in some cases, may not be as relevant in other cases.
Things we did in the 5.0 conceptual side of things, we looked at achievement and accomplishment in Dolce and realised that each of them combines two matters, whether it's telic or atelic. I think just the memories may be wrong, and whether it's occurrent or perdurant. So that we can combine all these things any which way, and that lets us do.
And are they in 5.0 or in your?
They're not published 5.0. They're my kind of conceptual stuff. Some of it may or may not get it. In fact, all of the occurrent, all of the upper ontology, and every kind of occurrent was removed from 5.0 publication, which I told them is a mistake, because that includes events and life cycles, which they now want to put back without this framework. But it does reinforce the idea that came out of the breakout yesterday, that what most of us are doing is using the top slice of these upper ontologies, and then coming up with their own articulation at the next level down where these things are. But you might find our categories useful.
Okay, and so here, so amount of matter is what we call material entity. And okay, that's true, because we say that if you have a material entity and you have an amount of matter, then you just have one thing, which is obvious.
No, you have a quality.
No, but one thing. There aren't two things. When I have, so here is an amount of chalk. Here is a material entity that I'm only holding one thing in my hand. According to Dolce, there are two things here: an amount of matter and a material entity. We only have one thing.
Namely,
A material entity, which is also an amount of matter.
object. You have an object.
This is also an object, but it's therefore a material entity because object is a child of material.
Okay, this means that because since you make a unity assumption.
Yeah. Yeah.
So the only material entity you care with, you care about.
Care about.
You care about. Sorry. Okay. The only material entities you care about are those which are unitary.
No, we have object aggregates, we have objects, and then we have material entity, and those people who are interested in material entities which are neither objects nor object aggregates, which is many, many things in biology, can use material entity.
The thing you have in your hands now,
yes,
is just an object. So
well, at the moment, yeah.
Every object is a material entity.
Yeah, but the,
and if I crush
the
it,
distinction between amount of matter and physical object in Dolce is based on the fact that amount of matter does not have a unity.
yeah,
While a physical
yeah,
object does.
but the consequence of that, and that is a reasonable consideration, it seems at first sight, but if you think about it, it has the annoying consequence that I'm holding two things in my hand.
Absolutely, yes.
No,
You're holding one.
And now you two are dizzy. He says yes, you say no.
Wait, you have to say what you're holding.
He
That's
wants to ask you.
So what we're doing here is there's two things that are going on. One is debating whether or not it is correct to say Constitution needs to be an ontology, which is a whole other thing. So we've expanded the rest of our lives figuring out. Versus, this is what BFO asserts, this is what Dolce asserts. Now what?
Yeah.
What do we do? What do I those are like one's more pragmatic, I suppose, and the other one is something I'm not really sure how we have to resolve the correctness of the question.
Well, actually, it's actually potentially helpful in the following sense. If we could carry out experiments of this sort, we would take a group of potential users of ontology who have data sharing needs, and they're talking about matter, material, and so forth, and we ask them whether they would prefer this particular way of organizing these teams or that particular way of organizing.
What happens when you smash that piece of
Yeah, then you have an aggregate model.
So,
Or an aggregate
was
of-
this aggregate not there before?
No, of course not. But hang on. The aggregate of molecules was there before.
Of course. As well
Yeah.
as the piece of chalk.
Yeah, but the aggregate of cells inside you is there as well as the human
Yeah,
being.
but then you move the
It's
aggregate
Some of us
with the object.
refuse to use object and object aggregate because of this sort of nonsense.
But that's not enforced in the
It's not enforced. It's enforced by the ontology.
You don't want to argue about what's correct. You want to argue about how we approach.
Yeah, so everyone accepts that cells are part of organisms. And so aggregates of cells are parts of organisms. The aggregate of cells of Nicola is there now, even though we haven't crushed Nicola in a blender, so that we can identify the individual cells.
So there are individuals.
No.
That sounds awfully like there's doing
Only in the sense that there are two individuals, which is your heart and you. Your heart is part of you. That's harmless.
Okay, I suggested to take seriously the challenge proposed by Faust and to come up with a written answer to that challenge, because one of the challenges is indeed about constitution.
We finished our Faust paper months ago. Everyone else is still doing it.
Okay, let's look at
So you'll find the answer there. Boyan, I think, is next.
To take the empirical point of view rather than the moral point of view. I've worked with different scientific communities, and it's really interesting to note that in some, constitution is really important, that they really feel there are different properties associated with matter versus object, and others strongly feel that that isn't the case, and they want to see that. So I actually see both in terms of what's out there.
So it's a difficult question.
There's a general principle at work here. We encounter this on a regular basis. There are some cases when you need a rich and complex representation. And for some obscure cases, I'm going to use that word somewhat weird. Some obscure cases, you might need to track the individual molecule with the chalk. And there might be some practical benefit of having two different. I would acknowledge that might be the case sometimes. Something that's much closer to my day-to-day experience is the role stuff in the Python. I acknowledge that some of the time you need a rich and complex way of representing roles. But 99% of the time, my belief is you don't. So the question isn't you should or shouldn't have it this way or that way. The question is, when it's needed, you should have it available. And it should not be there and confusing everybody. It should be in some sense suppressed or hideable so that people cannot see it when they don't need it, which is 90% of the time. But if they encounter that situation where you normally need to separate out the object and what is constitutive, or I really need to have this separate entity, a fictional thing called Michael Uschold, who's acting in the role of Bauer on this particular run. Those fictional entities might be useful some of the time. But the principle that I'm proposing is find a way so that they can both seamlessly interact and be in the same ontology, but hide one.
Okay, so
I don't think so.
It's really a distinction between what we call a conceptual ontology as a conceptual model in the Zachman sense of the word, a concrete model of business problem space, not an abstract model of a solution, versus something that's more of the level of a logical model, but more what semantic web ontologists are familiar with creating, which is an artifact created to answer certain competency questions and do a certain job in an application. Now, some people would argue, and I tend to agree, that those should be in different languages. But certainly, to derive that kind of pragmatic ontology that you don't need all this extra stuff, but it just does the job, you should be deriving that from something. From an engineering perspective, you should be deriving it from something that is a conceptual artifact. Otherwise, you're just making it up.
Michael and I have had this discussion many times, and we are 100% opposed.
We are.
So I don't think it has anything to do with conceptual versus applied. And then we can do it, what degree of granularity you need to represent something, whether it's conceptual or not.
Yeah, and I think that I think that from the BFO perspective, the way we address your concern is we have BFOs very small, and then we have extensions, IAO, OB, and so forth, which extend BFO into specific realms where granularity of certain sorts becomes more
So
important.
principally it should be possible if my desire were to become true for BFO to handle constitution, there should be some way to extend.
We can already handle constitution. Parts of constitution is part of. We are made of molecules. Molecules are parts. We are made of cells.
So you can handle a situation where you have the two-step validity for
So we
That's what I'm saying.
piece of chalk here, which is also an aggregate of molecules. I crush the piece of chalk down to the molecular granularity. Now I just have an aggregate of molecules. We can express relations of precedence, transformation. Actually, we had a relation of transformation.
So you said the constitution is part. Do you have the extensional? Do you have an extensional areology or not?
I guess so. Yes.
Because if you do have the extensional areology, then the sum of parts is identical with the whole.
It is.
Which means
Yes.
which creates problems.
No.
What happens when the whole is mashed?
No, but remember, you are
this is the
not
motivation for
the sum of your molecules. You are not the sum of your cells.
This means that you
Because
do not have an extensional areology.
no, it does. It does. Of course, it does. You are the sum of your cells plus all the cavities, the intercellular spaces, the digestive
Yeah,
tract.
but not that thing. The thing you're holding it.
If there are gaps between the molecules, there are anything without gaps in the physical world. That would be.
So it's almost lunchtime. Do we want to try to kind of summarize?
Well, I wanted to show you what BFO looks like, and that's the continuant ontology, and that's the occurrent ontology, and it's all beautiful. And if you haven't seen the book, this is the book with a guide to BFO. So those of you who haven't seen it, you should know about it.
Actually, yes.
I have a clarification question. When Celia is her name? She's
Celia.
When she's trying to make this connection between categories in Dolce, categories in BFO, is she assuming that we have the same domain of quantification? Because that's certainly not true. And then you say,
I know,
in Dolce, it's a subcategory.
There have been a series of papers, I think you may have authored one of them, attempting to create mappings between BFO and Dolce. She takes all the contributions of all of those papers and tries to work out which ones are truly coherent on the basis of the documentation of BFO and Dolce, and then creates a final mapping, which she then tests by looking at the Dolce WordNet mapping and using that, generalizing that to do a BFO.
I doubt.
Well, you can.
It's good way to try, but I doubt it.
Well, you will have your opportunity to see the paper. In fact, I can ask her if she will send it to you if you wish.
So we thought we'd do for the first session this afternoon. Now, we're kind of maybe like a half hour off our normal schedule. So we can just see how we want to go. We might just, instead of actually having a half hour break for the coffee, we might just say, when coffee arrives, just go grab coffee and cookie or something like that, and come back down here, just sit back down sort of we'll see how things go. But there's two things we wanted to cover in the second session. Gary's going to be kind of exploring this issue of when you have kind of the same ontology, but different versions of it, different logics. We kind of already saw that this morning. And there's Dolce, different, but then there's like Dolce Light, which is written in OWL, but actually not a sub-theory of extended subtheory. So what ways are we using between those? Because that kind of issue is also coming with BFO, and actually with this new ISO standard that's being proposed, one of the issues is having every ontology that kind of conforms to that standard would have an OWL maximization and a common logic maximization. So in what sense does it mean that these are really the same ontology and those kinds of issues? So we'll talk about that in the second session. For the first session, we're thinking, so Stefano was kind of saying that it would be good to kind of look at, this morning we were talking about mappings, but to kind of think about mappings from kind of a logical perspective, as perhaps a way of moving forward. So we have these debates this morning about, say, different logical commitments. Is there some way that having a logical approach to this can at least frame the problems in a more defined way? And so I'm just going to maybe stay open up with a few comments, and then we can kind of get into maybe a little bit more kinds of discussion. So I guess like there's that expression of give me a lever and I can move the world. What we say in our lab is, give us the axioms and move the world. So the idea is that when we're talking, say this example, we're talking about BFO and DOLCE. So when we're talking about mappings between, so they're just saying how mappings, a problem with mappings is that mappings are fragile, since both sides of the mapping will change dependently. Mappings are expensive to maintain. And we kind of looked at a few examples of some mappings between the ontologies. But those are still kind of about the form. And this is something we can kind of discuss. I mean, I'm not going to ask, you can ask the question, what are mappings? I don't mean that in a facetious sort of way, but like when we're really talking about mappings in a kind of a logical framework, what are we talking about? So I'm just going to say a few words like from our perspective, and then you can kind of join in from your perspective of how you guys have used it within specifically within DOLCE. So the approach that we use is that we actually, when we do what we call verification, so what we do in our lab is we take the axioms of ontology and try to understand what are all the possible models, and it's partially a simple model, what are the possible satisfying implications of those axioms. Now, to do that, how do you do that? These models, they could be infinite. You've got a time line that's infinite. How do you represent that model? I could have an infinite number of models. How do I say I have all of them? So what we actually do is we use various mathematical theories. Now, we're not saying the mathematical theories are in the ontology, but the mathematical theories have been developed. And mathematicians understand what the models of those theories are. And what we do is we actually write translations. We write mappings between the ontology that we're analyzing, so say the DOLCE here, and we map it into various mathematical theories. So this is kind of the distinction that Stefano was mentioning earlier, right? So if I have a time ontology here, right? Now we can say that there's a translation between time and a particular theory of orders in mathematics. These are orders. These are not. This is not time. Time is here. But from a logical perspective, they're the equivalents there. Right? And so, I mean, time's a very simple example. Within DOLCE, you look at the theories of Harmony and Kitchen here. As I'm talking, she's done this work with DOLCE. There is the module for the present relation. There is the temporary part-good. There is the constitution, qualities, dependence, and so these are all are modules. And so the mathematical structures end up being quite intricate kinds of structures, more than just orders. But the idea is what we've been able to do is, once you've done that kind of mapping, so we've also done work, none of the PhD students are here right now, done a lot of work with Sumo. And so she has done the same thing, like taking Sumo. I think she did a paper at Voice last summer. She's Lydia Supplemental do this work. So she's done that with time, and she's done that with theory, topology, and Sumo, and some other work. So she's done that verification. So she can take the axis of Sumo and show with the suitable logical sentences. I'll show you some examples of those. You can show how that's important to this mathematical